So 17 was just like this. This is an example of one like 17, and this is one you're going to encounter here. This is sort of the goal of this section, is for you to work with the polynomials. For you to be able to multiply them, be able to subtract polynomials and such. So let's say that this is your backyard. Okay, the larger rectangle. That's your backyard, and in the middle of your backyard, you want to put a cement pad. Okay, and you know the dimensions of your backyard, and you know the dimensions of the cement pad, and you want to be able to find out how much grass you're going to need. So this red hatched area maybe is the amount of grass you're going to need. Now let's say for some strange reason you don't know the exact dimensions, but you have an expression for the dimensions here. Okay, and the way that you do this question is the same as if you would, if this was 20 feet and 30 feet or whatever. But what we're going to do to try and find this area that you need to grass, we're going to try and find the entire area of your backyard first, right? And then we're going to subtract the area of the cement pad that you're going to make. And whatever is left over is the rest of the yard that's going to be grass. So does that make sense? So we need to find the larger area. So let's say the blue square is area 1. So how do we find area 1? How do we find the backyard total area there? What do we do? Yeah, it's a rectangle, so we're going to multiply length times width. So the length is 2x plus 1, and the width is x plus 3. So that's going to be the total area of the backyard. The other portion here that we're looking for is the area of your concrete piece, or the inside area. So this is area 2. So how do I find an expression for area 2? Well, same thing, right? Length times width. So this is x plus 3 times x minus 2. Now, in order to find this, we need to take the entire area and subtract the inner area. So area total is going to be area 1 minus area 2, right? Which is going to be 2x plus 1 times x plus 3 minus x plus 3 times x minus 2. And if you remember, what I strongly urged you to do here is to make, a second set of brackets here, especially when you have a subtraction sign, right? Because you're going to need to remember later on to subtract all the terms that you end up getting in that product. Oops. Okay. Now, if you look at your number 17, does that look familiar to what you did with 17 there? Okay. So if we multiply this out, then we have 2x squared plus 6x plus x plus 3 minus x squared minus 2x plus 3x minus 6. Is that agreed? So again, here's the tricky part that you make sure you want to pay close attention to, is over here when you subtract all of these. But in this next step, you probably should take the opportunity to combine some like terms over here. Then we want to get rid of the brackets. We don't want to have any brackets when we're combining like terms, right? So we're subtracting x squared. We are adding 2x because we're subtracting a negative 2x. We are subtracting a positive 3x, and we're subtracting a negative 6 that turns into a plus 6. So does everyone see what I did there? Because this is super, super important. And students often mess up right here. All right, so you could combine these first before you distributed the subtraction, but I'm going to do that now. So again, I'm going to show you every step so you make sure you understand what's going on. I'm going to combine like terms here now. 2 minus 3 is negative x. So now we have a collection of terms, and we can start to identify like terms. So the x squareds we can combine, and that's going to be x squared, 2 minus 1. The x terms here, can combine those. That's going to be plus 6x, that's 7 minus 1. And then, of course, we have our constant terms there. 3 plus 6 is plus 9. So in this example, the area of grass that we're going to need, if that was your backyard, is going to be represented by this expression. Now, I know that when you're actually doing a backyard measurement, you would measure your backyard and you would do this sort of calculation to find how much grass you would need. However, the reason why this is important is that, let's just say, that this is a scale diagram, and you've seen blueprints, right, for houses. You've seen diagrams for backyards. If you want your backyard to look exactly this same shape, you want this, your backyard is this rectangle right here, and you want this rectangle to be in the very center, and this is the exact shape that you want, well, then you can, if you have an expression for what the area is going to look like for the grass, you can put whatever variable in there that you want, right? So let's say that the width of your backyard, okay, let's say it's 21 feet across, all right? Let's say it's 21 feet across. And you want to have this backyard this exact shape. Well, 21 feet, if this is the expression for the length, what is x? 2x plus 1 equals 21. What's x? 10. 10. So x is 10. So that means, now I just pulled these expressions out of my head. So this may not work exactly right, but that means that if you put 10 in for x, wherever you see x right there, then boom, you have the dimensions of the cement pad, and you can easily find the area of grass that you're going to need. The amount of grass you're going to need. You just plug 10 right there and 10 right there. Now, if you had a much bigger yard, let's say your yard was really big, like it was, 100 feet across, right, or 101 feet to make it easy, then x would be 50, right? So then you plug 50 in for x wherever you see x, and boom, all of a sudden you've got all your dimensions and all your areas. And this is the way that computer programs are made. They have expressions. So you can plug in, how big is your yard? Well, you say 21 feet. Boom, it does all this math, and it says you need, you need 100 square feet of grass. Boom. So that's the math behind those programs. You know what I mean? So anyways, you may not quite, maybe that's too much for you right now, I'm not sure. I mean, we're just talking about the skills here, but this is the reason why this math exists, is for technology, for these kind of computer programs that you can easily plug in different variables, and that's why we call this a variable, because it can change. The area can change depending on what input variable you put in there. All right? So that's an example of finding an area in between two shapes, or the resulting area, such as number 17 on 3.7, page 187.